So here you will learn how to rationalize denominators. Okay, so first question is 1 upon root 7. Okay, so rationalization means you have to take the denominator and multiply it with numerator and denominator. So when you multiply the same number in numerator and denominator, the resultant number will be 1, and if you multiply 1 upon root 7 with 1, the number will be unaffected. Okay, so another logic will be that the numbers given in the question are unaffected when you multiply the denominator of that number to numerator and denominator. Okay, and why you have done this thing? To simplify the denominator, to find out the number that is equivalent to your question, and that number is rational number. Okay, that is why you are doing such kind of thing. So what you will get in the numerator, root 7 into 1 is root 7 upon root 7 into root 7 is root 7 square, and root 7 square is 7 only. Okay, now you will move to question number 2. So here I will tell you another logic. Another logic is what? So here in the denominator you can see that root 7 minus root 6 is given. So here what you will do in rationalization? In rationalization you will do root 7 plus root 6. Okay, you will just change the sign. So when you change the sign, the denominator will become a minus b into a plus b kind of thing, and that will be very much helpful for you, because you will have to solve only a square minus b square. Okay, in the denominator. So denominator will be a kind of game for you. Okay, so when you will simplify, you can see that when root 7 plus root 6 is multiplied with 1, same number will be there, root 7 plus root 6. And in the denominator, it is very easy for you, because it is in the form of a minus b into a plus b, and you know, if such kind of question is given, then their answer will be a square minus b square. So a square is what? A square is root 7 square. Okay, and b square is what? So as per your question, it is root 6 square. Okay, now you can see that in the numerator you will have root 7 plus root 6. Okay, and in denominator root 7 square is what? 7 minus root 6 square is what? 6 only. So in the numerator what you will have? You will have root 7 plus root 6, and in the denominator 7 minus 6 is what? 1 only, and 1 cannot be written in the denominator. So this will be your answer. So we do rationalization to simplify our question, and now it is very much evident to you that the digits are the same except the sign. You have to change the sign in the third question as well. So you will do what? So you will multiply root 5 minus root 2 to both numerator and denominator. So it will have no effect on the question, because root 5 minus root 2 in numerator and denominator will cancel out each other, and resultant number will be 1. So your question will be unaffected. But the advantage of doing this is to gain in the denominator the form of a plus b into a minus b, and you know, when such type of condition you create, then it is very easy for you to get your answer, because you will now have to do only a square minus b square in denominator. So in numerator you will have root 5 minus root 2. So root 5 minus root 2 you get in the numerator, and in denominator root 5 square is 5 minus root 2 square is 2. So root 5 minus root 2 is what? It cannot be subtracted, because the values are different, their bases are different. So root 5 minus root 2 cannot be subtracted. So root 5 minus root 2 is upon 3 will be your answer. Now moving to your fourth question. So fourth question is very easy for you, because you have learned the things. So you will multiply with opposite numbers in the denominator, that is, you will change the sign and multiply it to numerator and denominator. And in denominator you will get a minus b into a plus b kind of thing. So it is very much helpful for you, because you will get a square minus b square kind of thing. Now in the numerator you will have root 7 plus 2 upon root 7 square is 7 minus 2 square is 4. So you will have root 7 plus 2 upon 7 minus 4 is what? 3 only. Okay, so I hope you learned the concept. Okay, stay tuned for more such videos. Till then, happy learning. Bye bye.